that we have another VLAN, which is VLAN 30, which is for guests. So there can be many devices in each of the VLANs, and this is an access mode. So only the data related to VLAN 10 would be sent or received in using this line. Similarly in this and similarly in this, but these are trunk modes. So is this one from switch to the router. This can send or receive the data of any VLANs, right? But what if let's first go over all the advantages. So you can place the devices into various VLANs. It has following characteristics. It provides segmentation into various groups. As we can see that we have faculty group, we have student group, we have guest group. So we have segmented our organizational network into some hierarchy, right? This is also the way to make the network more manageable. So administrator can issue sorry, various set of commands or various set of settings on each of the VLANs to provide seamless services to each. Broadcast, multicast, and unicast are isolated. Yeah, we have studied that as well in the previous lecture. And each VLAN has its own unique range of IP addressing, because you can see that the faculty VLAN is having 172.17.10.24. This one is 20.25, 30.26. So guest VLAN is 20 dot something, and okay, this is strange. So I think this is a typo in here. So this should be 30. So in the guest VLAN, it should be 30.23, because 20.20 or something is in the student VLAN and 10 dot something is on faculty VLAN. So this leads to a question like, what if a faculty device wants to connect to a student device? We know that in this sort of scenario, faculty VLAN can communicate to another faculty VLAN, which could be at some other geographical location, right? But what if this faculty wants to connect to, say, just this student, or maybe this student, or maybe this guest? How could they do that? For that, the solution is inter-VLAN routing, which we will be covering in this lecture. So the focus is on inter-VLAN routing. In this chapter, we will be covering various inter-VLAN routing operation, which will be focusing on describing the options for configuring inter-VLAN routing. We will also be learning about router on a stick inter-VLAN routing and inter-VLAN routing using layer 3 switches. So we know that there can be two intermediary devices. One of them is router, another one is switch. So we will see how we can do inter-VLAN routing using that router or a switch. And finally, we will be learning about troubleshooting the inter-VLAN routing. Sorry. Okay, then let's start with the inter-VLAN routing operation. So we just discussed what the problem is in the sort of scenario that we have just covered. We need to provide inter-VLAN routing to communicate between different VLANs. So VLANs are used to segment switched layer 2 networks for a variety of reasons. We have understood, or we have thrown some light on what those reasons are. But regardless of those reasons, hosts in one VLAN cannot communicate in another VLAN unless there's a router or layer 3 switch. Why the host cannot communicate to another VLAN? Because that point was configured as an access and not the trunk. So the link will only be responsible to receive or send the data for one VLAN. But the router, as it has like a routing table and it has IP addresses, the router can eventually send the data from different VLANs having the IP addresses. So does layer 3 switch. An inter-VLAN routing process of forwarding network traffic from one VLAN to another VLAN. We have discussed that inter-VLAN means that you need to send or receive the data from one VLAN to another VLAN, be it on the same network, be it on a different geographical location. So it's communication between different VLANs, like a faculty VLAN with a student VLAN with a guest VLAN, or vice versa. There are three sort of options to do this kind of inter-VLAN communication. One of them is the legacy inter-VLAN routing. This is sort of the legacy solution. It does not scale well, and it is not nowadays. It's not used that much because we have new type of switches, we have new type of networks, we have new type of protocols. So it's not used that much, but we will learn about that. The second one is the router on a stick. This this is using just one router, right? It's an acceptable solution for small to medium sized network because they have that sort of configuration and they have that sort of devices placed in their networks. The third one is the layer 3 switch using switch virtual interfaces, and this is more scalable solution and it is used for medium to large organizations. We will learn in a bit more depth about all the three in the coming slides. So let me check if anything else is left now. Okay. So the legacy inter-VLAN routing is its sort of first inter-VLAN routing solution. It relied on using router with multiple Ethernet interfaces. Each of the interfaces was connected to one switch port in different VLANs. For example, if you have, say, a switch, say two switches, you have two switches and you want to create yeah, I mean, in this example, you can see that there's one router and one switch. So consider that you want to make two VLANs, right? Just using this one router and one switch. So you need to have two physical ports and two physical cables connected into one of the end would be connected to router and one of the end would be connected to switch. So if you want to have two VLANs just using one router and one switch, you need to have two cables connected to physical ports of either of the router as well as switch. So this would be one VLAN, and this one would be another VLAN in which you'll connect another physical cable into one of the ports of switch and one of the ports of router. So legacy solution, that's why it does not scale well, because it is limited by the maximum number of ports that you have in the router or the switch, right? So if it's a 48 port switch, you'd not be able to create more than 48. Or if it's a 16 port or 24 port switch, you'll not be able to create more than that sort of VLAN networks. So the router interfaces serve as default gateways on the local host on VLAN subnet. The legacy inter-VLAN routing using physical interfaces works, but as we have just discussed, it has very significant limitation. It is limited by the number of physical interfaces that your router and your switch has. So you'll not be able to create more number of VLANs as the number of ports that are available on either router or switch. And it's not nowadays, it's no longer implemented in the switched networks that we have in the organizations, and it's just for explanation purposes, like how it is used. So in this figure you can see that one VLAN is connected to this, so this link would be used for this VLAN. And I mean, it really depends upon the internal configuration, but just for the explanation point of view, you can consider that this VLAN is for this link. As we have just discussed, its limitation, like it does not scale well. It has another limitation as well. So what is the sort of acceptable solution to this? Because we do have a router in this, so one of the acceptable solution is the router on a stick inter-VLAN routing, right? The router on a stick inter-VLAN routing, it actually overcomes one of the very major limitation, which was having physical cables on connected to the physical ports of the switches. So in router on a stick inter-VLAN routing, you do not do that. So it's not limited by the physical cables that you need to do. So it only requires one physical Ethernet interface to route the traffic between multiple VLANs. So it's quite an advantage because you do not need, you do not particularly limit your communication by the number of ports you have on your switch or router. So that's that. And Cisco iOS router is configured using 802.1 Q trunk that we have just discussed in the one of the previous lectures, that how it can use the trunk port, right? It is connected on a trunk port on a layer 2 switch. And the router interface is configured using sub interfaces to identify routable VLANs. It's like just one physical link could be used as the sub links for different number of VLANs, just by using the functionality that we have discussed in the previous lecture. The configured sub interfaces are software-based virtual interfaces. For sure they are, because they are somehow, managed or administrated or configured using the software instances, and you can use the SVIs, the software virtual interface, to access the links. Each of the associated with a single, each of the SVI is associated with single physical Ethernet interface. So sub interfaces are configured in the software on a router. Remember, they are not configured on the switch, but they are configured on the router using software. That's why it's called router on a stick. The sub interfaces are configured for different subnet that correspond to their VLAN assignment. So one of the sub interfaces would be responsible for one VLAN, another sub interface configured on the router would be responsible for another VLAN, and this would intrinsically facilitate the logical routing between the different VLANs and inter-VLAN as well. So when a VLAN tag traffic enters the router interface, it is forwarded to that particular VLAN sub-interface. And once the routing decision has been made on the destination IP network, the router will determine the exit interface of the traffic. And if it is configured as a trunk interface or a 802.1q sub-interface, the new data VLAN tags are assigned, and it's sent back to the physical interface. One of the disadvantages, not particularly disadvantage, but if we talk about scaling, is that it would not be able to scale more than 50 VLANs, because the software configuration would be difficult to manage if it is more than 50 VLANs. Let's understand this more by using the NETCAD video that we have. Stop my camera because the bandwidth could be limited for some of you, so let me do that. Oops. So this is the router on a stick VLAN implementation that we have on the NetCAD. So you can see that there are three pieces connected to switch 2. Switch 2 is connected again with switch 3 and switch 1, which is connected to this router. So router has sub interfaces. It has just one. You can see that there's just one link, physical link or cable between the router and the switch, but it has three sub interfaces. So dot 10 is for VLAN 10, dot 20 is for VLAN 20, dot 30 is for VLAN 30. So these sub interfaces are configured using the software in the router. And if you can see that for switch port 1, these are trunk ports. They can take the data of any VLANs, and this is the access port, which is responsible for, this one is responsible for VLAN 10, this one's responsible for 20, this one's for 30. So what if this PC wants to communicate to this PC using this router on a stick sort of scenario? So to do that, you can see this video and see how it does. So a unicast packet is firstly sent from PC1 to switch 2. Switch 2 checks like what's the tagging of this frame, and as this is sort of just the access line, it cannot, although it was a unicast frame, it cannot just send to PC3 because it is tagged with the VLAN 10 ID. So as this is trunk port, it is sent to this switch, which again checks the tagged frame and sent to the router. Now what happens on the router is that this G0 by 0.10 received the frame using the VLAN 10 ID tag, but it now, using the software, it just converges or changes to dot 30. It's the logical conversion. It's not, you can see that there's no physical link in there. So it converts to dot 30, puts on that tag. Oops, okay. And now you can see that this tag contains VLAN 30 rather than VLAN 10. So this one is sent to the trunk port to switch 1. Switch 1 checks which trunk port it should send to. It sends to this one, and as this is access link for VLAN 30, so S2 would send this frame to PC3. And now PC3 does the same. It sends a unicast packet to S2. S2 checks the VLAN tagged frame and sends to S1, which again sends to R2. R1 now converts from dot 30 to dot 10 using the internal configuration, sends back the unicast frame to switch 1, which sends it again to S2, and which would send to the frame in and the VLAN 10. So what have we learned in this, or what have this video demonstrated? It demonstrated that this was, say for example, it was faculty, it was student and guest. So the faculty wanted to communicate with the guest using the inter VLAN. So you've just seen that how the router on a stick, just one single router, can help do this sort of inter VLAN communication. So the major takeaway is that it has the software configuration to make the sub interfaces in itself. Okay, let's go back to the slides. Sorry. So this one we have covered, and the inter VLAN routing on a layer 3 switch. So this is the video that we have seen was using a router, but we do have a layer 3 switches as well. So this is a layer 2 switch as shown by this symbol. This is a layer 3 switch as shown by this symbol. So most of the organization nowadays tends to spend a bit more to buy these layer 3 switch. So what does a layer 3 switch mean? It means that it works on layer 3 of the OSI model. So the OSI layer 3 is responsible for routing decision, and this one does the same. So it's a layer 3 switch, it would be using the routing tables and the routing decisions made. But you need to actually turn on that sort of feature to use this functionality. So the modern method of performing the inter-VLAN routing uses layer 3, as we have discussed that the organization tends to buy these layer 3 switches, which can perform more number of operations as compared to the layer 2 switches. A layer 3 switch is also called multi-layer switch. Yeah, it is also called multi-layer because it can operate on layer 2 as well as on layer 3. However, we just use the term layer 3 switch over the course of this module. So how does the inter-VLAN routing works on a layer 3 switch? Sorry. So this you can consider as VLAN 10, and this you can consider as VLAN 2. So we have two VLANs, right? The multi-layer switch has the functionality to use the SVI interface. As SVI interface uses the IP addresses, so it can actually check on the IP addresses and can use those IP addresses just as a router works. So you know how the router works for taking the routing decision and forwarding those packets. So just similar to that, the layer 3 switch would work, and it would use the SVI interfaces. So it would take the data from the SVI, from the particular VLAN, and send over to the next VLAN, because it has that capability in this switch. So the inter VLAN on the layer 3 are created in same way as we have configured the management VLAN. So in the one of the labs as well and the lectures, we have checked out how the management VLAN is configured on a switch. Similar to that, the inter VLAN SVAs are created on a layer 3 switch. The SVA is created on a VLAN that exists on the switch. Yeah, okay. Although virtual, the SVA performs same functions for the VLAN as a router interface would for the router. So it sort of copies the similar functionality of how the router performs and how the switch would perform the routing decision. Specifically, it provides layer 3 pre-processing of the packets that are sent to or from all the switch port associated with that VLAN. Yeah, that's fine. There are following advantages of using layer 3 switches. The very first one is that it's much faster than a router on a stick, because everything is sort of hardwire switch and routed, and there's no need for external links from the switch to the router for routing. It just every decision is taken on switch, so it's very fast. Also, one of the things to consider is that in the router, you would see that if there are more number of routers associated with the path, there the latency issues comes in picture, because as the packets would pass from one router to another, there would be processing done, there would be tags stripped off, there would be another tags created. So the more number of routers that comes into picture, the slower the whole process becomes. As this does not focus on the router, it does not have that sort of latency, so it's much more faster than in a scenario if we will be using a router. Okay, they're not limited by one link because layer 2 Ethernet channels can be used as trunk links to increase the bandwidth. Latency is much lower, as we have just discussed why the latency is lower. So they are more commonly deployed in a campus LAN than routers, or in a small organization structure as well, in which there are not many routers, but there are many multi-purpose switch, which is layer 2 or layer 3 switch. The only disadvantage is that these switches are more expensive than a layer 2 switch because they can perform more functionality. So that's the only disadvantage. If an organization has that kind of money to spend, or if they do not have that big of a network to manage, they can particularly use layer 3 switch, which would perform semi router functions and all of the switch functions. So a little test of knowledge. So what do you think this picture is about? Which sort of inter-VLAN routing does it portray? Does it portray the legacy inter-VLAN solution? Does it portray the router on a stick inter-VLAN solution? Or does it portray the layer 3 inter-VLAN solution? Give you 20 seconds. You can type in your answers in the chat. Oops, sorry. Okay, so thank you for your answers, and the answer is it's not legacy because oh sorry the answer is it's not router on a stick. It whoops let me just check. Okay, it's oops just a minute. Yeah, so the answer is it's the legacy inter-VLAN routing because we have the legacy instance and it is limited by the number of the physical links. So I'll like to address some of the. Did I turn on my mic?